So I have a total of 16 x squareds. And, well, now I have just y's and y squareds remaining. But y's are not the same thing as y squareds. They're different objects entirely. So I have 9 y squareds, and then I have 9 additional y's. And you can kind of see how typically a lot of people will write the exponents in descending order. So the squareds are bigger than the first powers. And by the way, remember that an exponent that's not shown is an exponent of 1. That's just a standard practice to show it that way. The next thing, next kind of concept where people often get confused is multiplication. So what if we instead multiply variables? Okay, well, let's say we, for instance, take x squared and we multiply it by x to the third. Okay, so now people are like, do I add, do I multiply, what do I do exactly? Well, going back to what the definition of an exponent is, it tells us how many times to multiply the base by itself. So in this case, we have x squared, which means take x, multiply it by x. X to the third means multiply x by x by x. So now by the definition of an exponent, I have x times x times x times x times x. Well, I have x multiplied by itself a total of 5 times. So notice what really happened. Because the bases were the same, the exponents ended up getting added together. So this doesn't really matter to what extent you go. It could be x to the third times x to the fifth. And if you went through the same process, well, x to the third means x multiplied by itself 3 times. X to the fifth means x multiplied by itself 5 times. So in total, how many times is x being multiplied by itself? Well, the answer is 8. And we can definitely test this if we did something like 3 to the second times 3 to the fourth. Well, if our argument is true that it's 3 times 3 times 3 times 3 times 3 times 3, that means I would have 3 multiplied by itself 7 times. And we can verify that this actually worked. So in our calculator, if we typed in 3, and you can either hit the caret button, which is this guy, and put in the 2 for the exponent, or for the power of 2, you can actually just press the x squared button here, and it'll put in an exponent. But the only problem is, for 3 to the fourth power, we actually have to do the caret sign and 4. So just like that, that would be 3 to the second times 3 to the fourth, and we get 729. So on the left-hand side, we would get 729. Now, if that's really the same thing as 3 to the seventh, what should that equal? Oh, I'm sorry, excuse me, 3 to the sixth. We have a mistake here. So this should be, we have 3 times itself 6 times. So we would do 3 to the sixth power, and hopefully we'll get 729. So we can see that it works out whichever way we do it. Well, what if you have something like 3x squared times 4x to the second? So what does that mean exactly? Well, that's, even though it doesn't look like it right off the bat, I could really remove all the parentheses and put in multiplication signs to indicate what we're multiplying. So we're really doing 3 times x squared times 4 times x squared. Alright, well, order of multiplication doesn't matter. For instance, we know that 2 times 3 times 4 is the same thing as 3 times 4 times 2. And you can prove that to yourself, that order of multiplication doesn't matter, it's commutative. So I can rearrange this to make it look more appropriate. So I have 3 times 4 times x squared times x squared. So all I'm doing is putting all my variables towards the back. So that means I have 3 times 4, which I can do is 12. And then x squared times x squared, well, we know that that's x times x times x times x. So that would give us 12x to the fourth power. So we basically ended up just multiplying the coefficients, and we ended up adding the powers of the x's. So this is a multiplication of bases. And what we've just determined is that if we have the same base, x to the a times x to the b, then we've noticed that it ends up becoming x, the same base, and we add up the powers together. Now be really careful with this, and I'm going to change pages so we can basically add all our properties in here. if you have x to the